They taught you a comforting lie in school. They told you that energy cannot be created or destroyed, that it only changes form. This is the first law of thermodynamics presented to you as an absolute, sacred, unbreakable rule of physical reality. And on its surface, it sounds perfectly reasonable. Energy in equals energy out. Nothing appears from nowhere. The books are always balanced. But here is the question that should have kept every physics teacher up at night, and somehow never did. If energy cannot be created from nothing, then look around you right now. Look at the light coming through your window. Feel the warmth on your skin. Think about the hundreds of billions of galaxies burning across the observable universe, each one blazing with the fury of hundreds of billions of stars. Where did all of that come from? If the first rule of physical reality is that nothing can be created from nothing, then how did literally everything come to exist nearly 14 billion years ago? Cosmologists have a habit of sliding past this question. They describe a primordial expansion, a hot, dense early universe, a first fraction of a second after the beginning, and then they bury the central problem under layers of abstract mathematics and move on. This video does not do that. Because the answer to this question is not that the laws of physics broke down at the beginning of time through some convenient miracle. The real answer is darker, more elegant, and genuinely disturbing, and it has everything to do with an illusion that you and every other human being who has ever lived have been trapped inside without knowing it. We think of energy as a presence, a flame burning, a planet moving, the blinding output of a star. Energy, in our intuitive mental model, is always a positive quantity, something that exists, something you can point to and measure. But we have collectively overlooked the one force that quietly shapes the architecture of all reality, gravity. And gravity carries a secret that most scientific communicators choose not to say out loud because it sounds like it belongs in a science fiction script rather than a physics lecture. Gravitational energy is, by precise mathematical definition, strictly negative. To understand what that means and why it changes everything we think we know about the origin of the universe, I want you to try a thought experiment. Forget the stars and the galaxies for a moment. Forget everything you know about the cosmos and start with something simpler. Imagine standing on a perfectly flat plane that extends in every direction as far as you can see. This plane represents absolute nothing, a state of exactly zero energy. No matter, no light, no movement of any kind, a true blank slate. Now imagine you want to build a mountain. You cannot import material from somewhere else, because doing so would violate the foundational rules of physics. All you have is what is already there, nothing. So you pick up a shovel and you start to dig. You excavate an enormous hole, and all the earth you pull from that hole you pile up beside it. When you are finished, you have two things, a towering mountain on one side and a deep pit on the other. The mountain represents all the matter and radiation in the universe, every atom, every galaxy, every photon of light, every unit of energy that can be seen or measured or touched. The pit represents gravity, and critically, crucially, the total amount of material you moved to create both of them is exactly zero. You built everything from nothing, and the books balance perfectly. The mountain and the pit are not just a convenient analogy. They are a precise mathematical description of the physical structure of reality. And understanding why requires working through the logic of gravitational energy one careful step at a time. Because this is the part that most popular science communication glosses over, and getting it right is the difference between a comfortable story and an honest reckoning with what the universe actually is. Gravity always attracts. This is not a detail, it is the core of everything that follows. If you have two massive planets sitting in space and you want to move them apart from each other, you have to spend energy doing it. You have to fire enormous engines, fight against the invisible pull connecting them, and push them outward against that attraction. You are spending positive energy from your own reserves to achieve the separation. If the act of pulling them apart to a state of zero interaction cost you positive energy, then by straightforward mathematics, the state they were in when they were together, when gravity was actively connecting them, must have been worth less than zero. Their gravitational connection represents a deficit, a debt, a negative quantity on the cosmic balance sheet. Now scale this up to the entire universe. Every piece of matter in existence is gravitationally connected to every other piece of matter in existence. The entire web of gravitational attraction threading through hundreds of billions of galaxies represents an incomprehensibly vast quantity of negative energy. And here is where the calculation produces a result that stops the conversation cold. If you were to add up every unit of positive energy contained in all the matter and radiation in the observable universe, every atom, every photon, every unit of kinetic and thermal energy, and then subtract from that total the negative energy represented by the full gravitational field, holding all of it together, the result the equations produce is exact and unambiguous. The sum is zero. The universe has never violated the first law of thermodynamics. Not once, not even at its very beginning. It obeyed that law in the most ruthless and elegant manner imaginable by constructing this entire theater of galaxies and light and complexity without spending a single net unit of energy. The mountain was built entirely from the material excavated to create the pit beside it. We are, in the most literal physical sense, the result of a self-balancing fluctuation. We are the Earth pulled from a hole that was dug 14 billion years ago, and the total cost of our existence, measured in net energy, is exactly nothing. This realization is both liberating and immediately unsettling. Because if the universe is a zero-sum game, if all this majesty is simply the division of nothing into equal positive and negative portions, then we still have not answered the deeper question. What moved the first shovel? What mechanism within the hidden structure of physical law decided that perfect, peaceful nothingness was unstable and needed to fracture into this churning dance of matter and gravity? Understanding that the universe is free does not tell us why it chose to exist. And that question, the one that truly will not let you sleep, requires us to confront something even more uncomfortable. We need to look at the nature of the Big Bang itself, not the version taught in schools, not the popular image of a great explosion scattering chaos across the void, but the thermodynamic reality of what that moment actually was. And when we do, we find that the comfortable story does not survive contact with the second law of thermodynamics. Not even close. There is a law of physics that is, in practical terms, even more ruthlessly absolute than the conservation of energy. It is the second law of thermodynamics, and it governs the directionality of every process that has ever occurred in the history of the universe. Its statement is simple and its implications are total. Things move from order toward disorder. Structure breaks down. Organization disperses. Complexity decays. Drop a glass on a tile floor and it shatters into fragments. In the entire history of the universe, no one has ever watched 1,000 fragments of broken glass spontaneously rise from the floor and assemble themselves into a perfect vessel. Disorder increases, always, without exception. This tendency toward increasing disorder is called entropy. Follow this logic carefully, because the conclusion it leads to is one that most cosmology documentaries carefully avoid stating out loud. If the universe today has a certain level of disorder, and yesterday had slightly less, then tracing this trajectory backward in time means that the universe at its very beginning, at the moment of the Big Bang, must have been in a state of almost perfect order. Not moderate order, not reasonable organization, near absolute, immaculate architectural precision. Now think about what the word explosion actually means. An explosion is maximum chaos. It is the violent, instantaneous conversion of structure into disorder. If you place an explosive device inside a junkyard, you do not expect the detonation to assemble the scattered metal into a functional aircraft. You expect rubble, dispersal, and devastation. Yet the birth of our universe, erupting from a state of infinite compression and heat, produced conditions so precisely calibrated that stars could form, planets could orbit, and creatures capable of asking questions about their own existence could eventually emerge from the arrangement of atoms. The cosmos did not begin in chaos. It began in a state of extraordinary, almost impossible structural perfection. And the mathematics of what that means are genuinely staggering. The probability of our universe emerging from the Big Bang with this precise level of initial order by pure random chance is not small. It is not negligible. It is not a number that rounds to zero in any practical sense. It is a number with more zeros than there are elementary particles in the entire observable universe. For all meaningful purposes, the probability is mathematically zero. Our origin was not an accident. The initial conditions of our universe were tuned with a precision so extreme, so specific, and so demanding that it requires a deep explanation, and standard physics, which is very good at describing what happened after the beginning, offers no explanation at all for why the beginning looked the way it did. This is the wall, the logical barrier that the comfortable version of cosmology pretends does not exist. How does supreme order emerge from primordial fire? How does a universe that should have begun in chaos instead begin with the architectural precision of a master blueprint? The answer does not live inside the standard model. It lives in what came before, in a direction that most of the scientific establishment has been reluctant to look, because what you find there does not just answer the question. It demolishes the premise entirely. To understand what was before the beginning, we have to challenge the most basic concepts. We think we understand space, time, and the meaning of size itself. Here is a question that sounds simple until you actually sit with it. What does it mean for something to be large? Right now you can measure the distance between your hands. You can watch seconds pass on a clock. You can stand in a room and perceive its dimensions with complete confidence. You can do of this because you are made of matter particles with mass. And mass is the physical anchor that makes the measurement of space and time possible. Without mass, there is no ruler. Without mass, there is no clock. Size and duration are not abstract absolutes. They are properties that only have meaning because material particles exist to define them. This is not philosophy. This is a precise consequence of Einstein's theory of relativity, and following it to its logical conclusion reveals something about the structure of the universe that shatters ordinary intuition completely. Travel forward in time not thousands of years, but trillions upon trillions of years into the deep future of our cosmos. The stars have exhausted their fuel. The galaxies have dissolved. The vast web of structure that defines our universe today has unwound into a cold, dark, effectively empty expanse. The only significant objects remaining are supermassive black holes, gravitational monsters, consuming the last remnants of dead matter at the centers of what were once galaxies. But even they are not permanent. The work of Stephen Hawking demonstrated that black holes slowly leak energy into space through a process of quantum thermal radiation. Given enough time duration so vast they are genuinely beyond meaningful human comprehension, numbers written as 1 followed by 100 zeros, even the most massive black holes evaporate completely, returning their energy to the surrounding void as pure radiation. At the absolute final end of time, the universe contains no atoms, no mass of any kind, only photons, particles of pure light crossing an infinite dark expanse. And here is where the trap closes. A photon has no mass. According to relativity, a massless particle traveling at the speed of light experiences zero elapsed time between its creation and its absorption. For a photon, there is no journey, there is only an instantaneous transition. Space, similarly, contracts to nothing from the photon's reference frame. For light, distance does not exist. Now apply this to a universe composed entirely of light. A universe with no mass has no ruler and no clock. It has lost the physical capacity to measure its own scale. An infinite, cold, expanding void filled only with massless radiation becomes mathematically indistinguishable from an infinitely hot, infinitely compressed, infinitely small point of pure energy. The equations collapse into one another. The enormous becomes identical to the microscopic, not as a poetic metaphor, but as a precise geometric equivalence. Theoretical physics has a formal name for this property. It is called conformal invariance, the condition in which the laws governing a system contain no meaningful notion of absolute scale. When the last particle of matter in the universe disappears and only radiation remains, the cosmos enters a state of perfect conformal invariance. It forgets how large it is. And a universe that has forgotten how large it is becomes, in every equation that describes it, identical to the birth state of a new universe. The end of one cosmos is the mathematical beginning of the next. The Big Bang was not the start of everything. It was a transition, a geometric seam connecting the infinite cold death of one universe to the blazing compressed birth of another. We have now established something extraordinary through careful, step-by-step physical reasoning. The far future of a dying universe, vast, cold, empty of matter, filled only with light, is mathematically identical to the initial conditions of a new Big Bang. There is no physical boundary between them. There is no moment of true nothingness separating the death of one cosmos from the birth of the next. The geometry simply transitions, the way one side of a coin transitions to the other, without either side being aware of the boundary they share. I call each of these phases an aeon. We do not live in the first universe that has ever existed, and we will not live in the last. We are one link in an infinite chain of sequential universes, each one expanding across trillions of years, cooling and emptying, losing its geometric memory of scale, and in that very forgetting becoming the ignition point for the one that follows. Our cosmos inherited its existence from a predecessor, and it will bequeath the conditions of its own death to a successor that will never know our names. This framework does something else that standard cosmology cannot do. It answers the question that stopped us cold in the previous section, the seemingly impossible problem of the initial order of our universe. The Big Bang did not create that extraordinary architectural precision from scratch. It inherited it. The infinite expansion and absolute cooling of the universe that preceded ours smoothed every irregularity, stretched every wrinkle in the fabric of space until it was perfectly flat, and delivered to our beginning a starting condition of near-perfect order, the precise thermodynamic foundation that the second law of thermodynamics requires us to find when we trace our universe backward to its origin. The order was not a miracle, it was an inheritance. But as a physicist and a scientist, I am not satisfied with mathematical elegance alone. A theory that cannot be tested against observable reality is philosophy, not physics. If there was a complete universe before ours, if our Big Bang was a transition from a previous aeon rather than a creation from nothing, then the laws of physics demand that evidence must exist. Transitions leave marks. The past writes itself into the present in ways that careful observation can uncover. The question is where to look. You cannot point an optical telescope at events that preceded our own universe's timeline. The visible light record only reaches back to when our young cosmos cooled enough to become transparent, a wall of light called the cosmic microwave background. This ancient radiation fills the entire sky, a faint thermal echo of the first light that escaped freely through our universe. Cosmologists typically describe this background as almost perfectly uniform, a smooth, featureless glow. But uniformity was never the whole story, and the marks left by the aeon before ours are hidden inside the subtle temperature structure of that ancient light if you know exactly what to look for and have the willingness to find it even when it challenges the foundations of accepted cosmology. In the universe that preceded ours, supermassive black holes dominated the gravitational landscape of dying galaxies. As that previous aeon expanded to its infinite cold conclusion, those black holes evaporated through Hawking radiation over incomprehensibly vast timescales, releasing the energy equivalent of billions of suns into highly concentrated regions of empty space. When the conformal transition occurred and that dying universe became our Big Bang, that concentrated ancient energy did not disappear. It crossed the boundary, carrying the imprint of those evaporated black holes into the structure of our newborn cosmos. If this reasoning is correct, that energy should have stamped its signature into the cosmic microwave background not as a subtle statistical whisper, but as distinct, measurable anomalies, concentric rings of slightly elevated temperature, points in the sky that are warmer than any standard model of the early universe can account for. I call these features Hawking points, and we went looking for them. Science lives or dies by what the data actually says. Beautiful mathematics drawn on a blackboard is a starting point, not a conclusion. So when the theoretical framework of sequential universes predicted that specific, measurable anomalies should appear in the cosmic microwave background concentrated regions of excess thermal energy, concentric rings stamped into the oldest light in our universe by the evaporating black holes of the aeon that preceded ours, the only honest response was to go and look. We analyzed real observational data from satellites that have mapped the cosmic microwave background with extraordinary precision. We were not looking for vague statistical suggestions or ambiguous patterns that require creative interpretation. We were looking for specific, physically predicted features, points in the sky significantly warmer than the standard cosmological model can explain, and large-scale ring structures that have no place in a universe that began in perfect homogeneous simplicity. We found them, not one or two, dozens. Precise locations in the sky that are measurably, significantly hotter than any model of a universe born cleanly from nothing can account for. Ring structures of elevated energy in the deep sky that have no legitimate origin within the standard framework of early universe physics. These are not numerical artifacts or measurement errors. They are empirical wounds in the oldest observable record of our cosmos, the thermal fingerprints of black holes that lived and died in a universe that ended before our time began, their dying energy crossing the conformal boundary of the Big Bang, and impressing itself permanently into the fabric of our own reality. The scientific establishment's response to these findings has been, to put it plainly, uncomfortable, because accepting what the Hawking points represent means accepting that the most fundamental assumption in standard cosmology that our universe began from nothing at the Big Bang is not merely incomplete, but structurally wrong. It means accepting that our Big Bang was a transition, not a creation, that our cosmos has ancestors, that the ordered precision of our initial conditions is not a miraculous accident requiring no explanation, but a direct physical consequence of the smooth, cool, structurally exhausted state of the universe that died to give birth to ours. The evidence is in the sky. It has been there from the beginning, staring back at every civilization that ever pointed instruments at the heavens. The cosmos does not begin and end. It cycles expanding across trillions of years, cooling into geometric forgetfulness, transitioning through the mathematical equivalence of the infinite and the infinitesimal, and igniting again in the structured fire of a new creation. We are not miracles conjured from an empty void. We are matter in transit, temporary concentrations of organized energy, children of the infinite and mathematical parents of the Big Bang that will one day follow ours. The supermassive black holes forming at the centers of our galaxies right now will outlast every star in the sky. They will outlast the galaxies themselves. They will evaporate across timescales that dwarf the current age of our universe, and their concentrated Hawking radiation will cross the conformal boundary of the next transition, leaving its own ring-shaped scars in the cosmic microwave background of a universe that does not yet exist. We will be their Hawking points. The universe does not owe you comfort. It does not owe you simple answers or reassuring boundaries that keep the existential darkness at a safe distance. But if you have the intellectual honesty to follow the mathematics wherever it leads, past the comfortable lies of school textbooks, past the standard model's careful evasion of its own deepest questions, past the instinctive resistance of a human brain shaped by the short timescales of savanna survival, what you find at the end of that road is not emptiness. It is a structure of breathtaking, almost unbearable elegance. A universe that costs nothing to create, that writes its past into its own oldest light, that recycles its own death into the raw material of rebirth across an eternity of sequential aeons. I am Roger Penrose, and that is the real architecture of our cosmos. If this journey through the true structure of physical reality has shifted the way you understand your own existence, do not let that shift fade with the video. Share this with someone whose thinking deserves to be challenged. Leave your reaction in the comments. Do you believe the Hawking points are real evidence of a previous universe, or do you think there is a deeper explanation still waiting to be found? Subscribe now and stay with this channel, because the questions we are just beginning to ask will take us further into the genuine nature of reality than anything you have encountered before.